Data has never been more important than it is now, but while we have a lot of data that we can access and our algorithms and LLMs can access, it's in various forms, structured and unstructured. So I'm really pleased to be able to discuss the challenges of structured, unstructured data, how to organize it, with Professor Karin Verspoor. She's the Executive Dean of Computer Science at RMIT University. So welcome, Karin.
Thank you. Thank you so much for having me.
So Karin, you had a strong background in analytics, but you've also been applying that for over 20 years or so in healthcare. Can you perhaps discuss your journey? Because I understand you didn't start as a healthcare professional, you started as more of a data scientist, analytics person. Can you just describe that journey that you took?
Sure. It's actually been a really fun journey, so I'm happy to talk about it. I started off studying computer science as an undergraduate student. And along the way, I discovered something called cognitive science, and I was able to take AI classes alongside of psychology of language classes and linguistics classes. And so as a student, I was exploring this interdisciplinary space between language and computing. And I had an aha moment when I realized that the things that they were talking about in the psychology of language class were really the same things that they were talking about in the AI class, trying to get computers to make sense of language using formal grammars and using kind of structured representation of language and knowledge-based reasoning and logic and all of these things. And I thought, wow, if we can get computers to do this stuff, that'll give us insight into how the brain works and hopefully make sense of all this crazy stuff we can do with language. And it just sparked something in me, and I needed to do more. So I ended up doing a master's and a PhD at the University of Edinburgh, specifically in cognitive science and natural language processing, and at that intersection of computer science and cognitive science, and with a specific focus on language. And that got me into things like knowledge representation, because as soon as you start talking about language and the way information is communicated through language, the way meaning is expressed, you have to think about knowledge and how that connects to the way we express knowledge and the way we communicate information. And so my PhD ended up being about essentially how to represent words and their meaning and how they're connected to each other. And I started really thinking about language in relational terms, understanding that words in isolation don't tell us anything, that we have to look at the words in combination. And in linguistic terms, this is pretty straightforward. Like, we have nouns and we have verbs, and we use the verbs to connect the nouns together to express relationships between things. But from a computer science perspective, this really means thinking about what are the core ways of representing those relationships and how we can get a computer to make sense of it. All of which is to say, it gets me thinking about data and how to represent it, because to get a computer which is just trying to process ones and zeros and binary numbers and doesn't really understand these things that we communicate with, to make sense of that, you have to map it into a model which is much more structured and logical. And so that started me down my path.
Yeah, so the word that springs to mind as you're talking about that is context, because you mentioned that individual words don't make a lot of sense unless you see them in context. And a lot of what we understand now about how to use the ChatGPT, Claude, is that you've got a limited sort of context window in order to explain to the LLM what it is that you're interested in. And outside that, then it has to go and search the web for things or use whatever data has been trained on. But if you want something really specific to your context, you have to be very clear about that. That is conveyed to the model. So you've probably been quite prescient in that career choice, because at the time you did it, organizations probably needed supercomputers in order to manage the data. And I think you had access to some supercomputers, but now we have a lot more access to data and computing capacity to be able to bring that to life. Can you perhaps explain, you were doing analytics in a context that was very science-based, and then somebody asked you about healthcare. what was that would have required a learning on your part for what are the key parts about that industry. So can you explain what sort of journey you had to go through to understand healthcare without and relate that to the data models without having a healthcare background?
Yeah. Actually, so it started with molecular biology, believe it or not. So I obviously started with natural language processing, and then I had a number of, let's say, experiments in the early part of my career where first I started down the traditional academic path and did a postdoc after my PhD, but ended up in a situation where I was living in the New York area, needed a job, and ended up in an AI startup, in fact, because that seemed like the most exciting opportunity at the time. But this was late 90s, and in the early 2000s, essentially the bottom fell out of the digital venture capitalist market. And so all of the startups that were nascent at that time, or not all of them, Google survived, right? But many of them failed at that time. And so I had to find another job. And you alluded to supercomputers. So I ended up eventually at Los Alamos National Lab, where I was trying to get back into some research after the time in the startup industry. And the very first day I was at Los Alamos, one of my colleagues said to me, "Oh, you do this natural language processing stuff. I think maybe we can use your skills in my project." And I said, "What's your project?" He said, "Oh, it's about protein function prediction." And I literally looked at him and said, "What's a protein?" Because I hadn't had any biology since year 9 in school. But then I said, well, you know, I have nothing better to do. I just got here. Let's explore this. And so that got me started. And what it made me realize is that there's a huge amount of information in science, but also in medicine, that's communicated in the scientific literature. So everything we do in terms of biomedical research is written down and shared through publications, which is language, right? It's expressed in language. And so the first project that we worked on around protein function prediction actually was about trying to machine read scientific papers to pull out information about proteins, how they were interacting, again, those relationships, and trying to organize the information around molecular biology in order to contribute to understanding what proteins are doing in our body. Now, this gets you very quickly towards health, right? Because a lot of what we care about, why do we care about understanding protein function? It's mostly so that we can start thinking about how to manage disease and basically interfere with what proteins are doing when they go wrong, or enhance what they're doing when they're doing good things in the body. And so the connection between protein function and health is basically drugs, right? And trying to work out how proteins and drugs interact in the body, and then how they're connected to disease. Now, all of this is described in scientific publications. That research is trying to figure all this stuff out. So what we were doing was building tools that would try to trawl through the massive amounts of research literature that were coming out and try to pick out, there's a connection between this protein and this gene and this disease and this chemical, and build those relationships. But because words are so complex and the amount of information that's available in the scientific literature is so vast and growing exponentially now, we had to use computer tools, computational tools to access that. And that then means we need to use natural language processing because we're trying to get at that. And then in terms of learning the healthcare context, like I said, I knew nothing about proteins. I knew even less about medicine and how to connect proteins to disease. But, you know, sometimes you just need to dig in and learn something new. You know, along the way, I wouldn't say I have a deep knowledge of any of this, right? But I've been exposed to it and just try to make sense of by making sense of the language, by making sense of the words that were being used to describe, using words like phosphorylation and methylation and ubiquitination, which, you know, I first looked at and thought, is this English? Yeah. But then just a little bit of knowledge was enough to kind of allow me to contribute something using the skills I did have. And then eventually electronic health records were coming online. And I, realized that, oh, wow, okay, the same problem we have in the scientific literature with all of these words being used to communicate really important information is happening in the context of electronic health records, where, language is the most natural way to capture information for people, because that's how we express and communicate information. And so all of the documentation that was being captured in electronic health records then became my next challenge, right? Thinking about, like, how can we get access to that information? There's, of course, you started off talking about structured and unstructured data.
I was going to circle back to that, because every discipline, and the medical discipline isn't one discipline, it's a bunch of sub-disciplines, and you can think in other industries it's also the same. In financial services, there's retail, there's institutional, there's corporate, there's wealth, there's a whole range of different things, and each sub-discipline has its own body of knowledge, and certain words mean certain things. And if you use the wrong word or the right word in the wrong way, then you can get a lot of confusion. You get the wrong results. Can you walk through what are the different bodies of knowledge within the medical discipline that have tried to coalesce around standards, terminology for things, and a way of structuring information? What does that look like?
Yeah, so it's actually quite remarkable. Maybe 40 years ago, the National Library of Medicine was established in the US, part of the National Institutes of Health. And their job was basically exactly what you just described, to organize the nomenclature around medicine. And they developed something called the Unified Medical Language System, the UMLS. And it is a structured representation of words, synonyms, relationships between things in a hierarchical organization. It builds on a number of different standards that have developed over time, including the International Classification of Disease, ICD, which is a coding system, basically trying to catalog all the diseases that are known. Obviously, always expanding as knowledge moves forward, but organized hierarchically. So you have respiratory diseases over here and cardiovascular diseases over there, mental health diseases over there. And so, it has a really, really important structure. Actually, that structure has become the foundation for billing in many health systems around the world, because, it's sort of tied to diagnosis and treatment, and that then leads to service fee recovery and that sort of thing. But so we had International Classification of Disease. There was also a vocabulary called SNOMED, which captures the signs and symptoms and the language around that. Again, developed by clinicians for the purpose of removing some of that ambiguity and making sure that they had clear terminology systems that they could rely on. Now, in practice, people don't always use the terminology correctly, as you said, but these systems were designed to kind of help give some structure around the terminology. And it was based on a consensus process, building taxonomies and ontologies by experts, and designed to reflect all of that. And so the National Library of Medicine kind of brought all this together. Unified Medical Language System means that they've taken all these different standards that have kind of evolved independently for various different reasons and tried to give a unifying structure on top of it, which said, oh, okay, this SNOMED symptom term over here connects to this ICD disease term over here, and they're related explicitly by the fact that they share vocabulary.
So if it was done 40 years ago, it probably wasn't digital originally, but that sort of information structured that way, I would expect, would be that map would be readily digitized, and it could be useful context for any natural language processing that's attempting to understand a clinical report or a diagnosis or something of that nature. How do you ingest or bring that context into a system? Because there are some quite advanced computer systems, some organizations are very large and able to manage such a large amount of data, but there are other areas where an organization may be much smaller and doesn't have a supercomputer or a data center in the backyard. How how do applications make use of that map when they walk through a couple of use cases for that?
So maybe first of all, in terms of like how it was used initially, it was actually driven by the library, right? So back, we were doing Dewey Decimal System and, indexing of books and journal articles for a long time before we had digital systems. And that was all, again, about, just trying to catalog things, right? And keep track of them in a systematized way. And so the library actually was the initial impetus for the National Library of Medicine to try to develop these coding systems. But for sure, when the digital systems came online and we moved to digital libraries and we moved to electronic health records, they became immediately useful, and they give this kind of anchoring framework for everything. In terms of like what can a small organization do versus a larger organization, it is an ecosystem. So you do have some of the bigger players that were really trying to make sense of the data and developing tools to help the smaller businesses do that. So GE Healthcare, for example, developed an automated detector for these international classification of disease codes and would essentially sell that to hospitals or sell that to service providers to help them detect these codes and manage them, again, for billing purposes primarily. But a lot of the methods that were being developed 30 years ago or probably 30 years ago now were very simple and sometimes just meant dictionary lookup, right? Because we had this massive resource of vocabulary in the UMLS. They could simply just map the terminology that was in the records directly into the vocabulary that's in these resources. Now, in practice, natural language is not that neat, right? Especially if you think about the medical context and the use of negation, like, a huge amount of the diagnostic process in medicine is ruling things out. So you want to say there's no evidence of this, or, this test came back negative. And so if all you do is look for the test, or you look for, the name of the disease, you kind of have a problem because you're going to be saying, oh yes, they said there was, an infection, but in practice it said no infection. And so you have to do more than just dictionary lookup if you want to effectively capture it. But it's a starting point.
Sounds like telling a child not to do something when they don't hear the not, they only hear something.
It's exactly
that. They go
that.
ahead and do that.
But it's a starting point, and at least it tells you, okay, there's something related to infection that's being investigated, right? And so it's not the most terrible idea. It does leverage the vocabulary and leverages this investment that's been made into organizing the vocabulary and the nomenclature. So it's a starting point. And these days, of course, we have large language models and we have much more sophisticated machine learning methods that allow us to really factor in that context, like you were talking about earlier, which allow us to do a much more nuanced job of capturing this information. But there's still a connection to the structured vocabulary resources because of the fact that actually these big models we have today don't, by and large, have access to the full diversity of clinical documentation. And so there's still a gap between, what they've been trained on and the use cases in the clinical context. And that's where we need to introduce some knowledge and some smarts and some kind of domain-specific solutions.
So where do you see this heading? What do you see in the near to medium term of the evolution of this? Because I can see when you go to a GP is sort of has to carry a lot of information in their heads, and that's not the best way of relying on someone's expertise. They really should be able to tap into things. But what are the key things that you see evolving over the next, say, 3 to 5 years that we're going to be assisted by analytics and these data models?
So, the good news is that people, I think, now appreciate the value of the technology in ways that they probably didn't 5 years ago. Before ChatGPT came on the scene, if I would talk to people about, we can use real-world data, we can try to normalize the data, we can use natural language processing, we can use AI to model this data, most people were like, I don't need you. I can do my job without this. Why do I need this? And then when ChatGPT came out, something clicked and they realized this gives us access to information in a really different way. You know, you're no longer relying on your database specialist to write your SQL query to pull data out of a system. You can now potentially interact with this system in a much more natural way using words. I think people have realized the potential of this. Now what's happening is we're trying to catch up because people want to be able to do all sorts of things that they can do with ChatGPT in their practice that they can't actually do effectively right now.
Because there are consequences of getting it wrong are quite severe. So what are the controls that you see are needed or being worked on to help ensure that the model doesn't hallucinate and give you the wrong answers? I think it probably goes back to the quality principles stemming. You need to make sure you build quality in rather than always relying on quality by inspection, because any rules that you may sort of impose, the rule set needs to be updated. What validation techniques do you see evolving to help ensure that we don't make big mistakes?
Yeah, I mean, people are very aware of the downsides of LLMs and the generative models in particular. And so there is very careful progress, right? I think people in the clinical space have adopted things like AI scribes or these documentation tools that help them to, basically listen to a conversation and transcribe or more accurately summarize the conversation. And explicitly, we're relying on the humans being the quality controls. There's doctors have to tick a box that says, I've read this and I agree that this is an accurate summary of our discussion. And that's certainly one way. I think we will see better tools to help the clinician make that decision because, humans are humans, and I do worry about somebody checking it 9 times really carefully, and it was right those 9 times, and the 10th time they kind of say, oh well, it was right the last 9 times. It'll save me time if I just tick the box and move on. Yeah. We want to avoid that, so I think we'll be seeing some tools being developed that kind of help the clinician to say, hey, there's a quality check that we've done here, and it seems like something might have gone awry. Pay closer attention, please. The other thing to say is that, to your comment about kind of rules and constraints, I think actually we will see more introduction of the old school methods where we're relying on some more controlled solutions, so that controlled algorithms. So it's not all generative. Some of it will be, simple information extraction and normalization. Some of it will be predictive models that are doing classification into for specific purposes, like trying to detect a disease from the data that's in there, which is not generative. It's saying, this is, it looks like this patient might have this disease, and critically having the human in the loop, right? So that it's not the entire decision being handed over to the machine, but rather information, that the machine is surfacing information for the clinician to be able to do their job more effectively.
So I feel more comfortable that you mentioned keeping humans in the loop. Given that you're an academic and you're involved in education, and I guess all of us need to continue lifelong education. Some of us are feeling, well, are these things going to replace us? What are the key things about domain knowledge that you would encourage people to focus on to make sure that they are going to still be the humans in the loop in this?
Yeah, well, it's definitely true that if you don't know something about the things that you're using the generative systems for, then you don't have a framework for doing critical analysis, for finding errors. You need to know things in order to judge the outputs of these systems. And so there is this tricky balance. Like we need to still be in control of the systems, and that means we need to know some things more than the LLM does. And I think actually it comes back to context, right? So I often ask the question, what's not in your data? And, you know, the LLMs have been exposed obviously to a huge amount of data, but they are not exposed to the specific context of where we're using them. They're not exposed to the particulars of the individuals. They're really good at aggregating and summarizing stuff that's been repeated thousands of times.
Summarizing and averaging.
But, you know, every situation is unique, and that's the thing that a human can bring into the picture that the LLM doesn't have access to.
Well, thanks very much for sharing that, Karin. I think it's relevant to all of us, regardless of whether we're in healthcare or data science or any industry or discipline, as we navigate this change in our landscape. Thanks very much for sharing.
Thank you for having me. It's been fun.